So discuss. Mm, let's discuss everything. Okay. So latches in digital electronics. So latches are the digital circuit that store a single bit information. Okay, so, latches is a digital circuit that stores the single bit information and hold its value until it updated by the new input signal. Okay, so actually it store one bit of information until when the updated signal of the input is not provided. Okay, they are used in digital system as a temporary storage. So it is used in a digital system as a temporary storage. Okay, the okay. Mm, okay. And okay, okay, and okay, and they are used in data circuits for temporary storage, and this one and storage of binary information. Latches are implemented using various digital logic circuits. So latches can be implemented using NAND or not NAND NOR gate. Okay, latches are widely used in digital system for the various applications. So it is used for the various applications, including data storage thing, controlling the circuit. Okay, so latches are simply not using one for it. It is also using for the different things like the data storage, controlling system, and the flip-flop circuit. Okay, they are often used in combination with other data circuit to implement the sequential circuit. Okay, such as uh, such as the state machine and the memory element. Okay, so we know the basic of the latches. Okay, so so move to the move to the definitions and these things. So latches are the basic. So latches are the basic storage element that operate with the signal level. Okay, rather than signal transition. So latches controlled by the clock transition by the flip flop. So latches are controlled by the clock signal transition by the flip flop. Latches are the level sensitive device and latches are useful for the device of asynchronous sequential circuit. Okay, so latches are sequential circuit with two stable state. So whenever we have to explain what is latch, first of all, notice me, latch is a detailed circuit that stored the single bit of information until when the new signal and the updated new signal is not provided, and it is a temporary storage for the binary information, and it is a basic storage that operate on the signal level, and latches are level sensitive. Okay, and when we have to say the controller signal and the latch are level sensitive on this latches sequence, and they have two stable state, and latches have two stable state, and these are the sensitive to the input voltage applied input voltage and does not depend on the clock pulse. Okay, so these are sensitive to the input voltage applied and does not depend on the clock pulse. Okay, flip flop do not use clock pulse refer as a latch. A flip flop or simply a flip flop that does not use clock pulse is known as latches. Okay, so how many types of latch in our digital electronics? So in our digital electronics, there are different type of latch: SR latch, okay, greater SR latch, D latch, JK latch, or T latch. Okay, simply, yeah. So SR latch means set or reset latch. Okay, are the simplest form of the latch and implement using two input. Okay, set and reset latch are the reset latch are the simplest latches that are implemented using two input. So S is stand for state set, or R for reset. The S input, the S set the input to 1, and while R reset the input to the 0, while both S and R input are 1. When both S and R input are 1, the latches is said to be undefined state. Okay, They are also known as preset and clear state. Preset and clear state. SR latch form a basic building block for the other type of latches. Okay, SR latch is a building block for the one. So truth table, when we have to create a truth table, so SNR 001010011011. So Q, okay, and Q dash input. So 0 latch, okay, 00000000. When two are all like 0, okay. Mm. Mm, uh, as a logic diagram, what is logic diagram? So as a latch of the logic circuit, two cross NOR gate and two cross NAND gate. Okay. So how we do? Simply NAND gate, NAND gate. Okay. S dash, S dash, R dash. One is this. The cross pulse it's on the input side and this is on from the this side. Okay. The logic diagram is here. Okay. And this is the NOR representation as a latch using NOR gate. Okay. In which S R in which S dash to Q and R dash to Q dash. Okay. In which R to Q and S to the Q dash. Okay. Different case of S. Okay. These are the SLS. One related note you don't need. What D latch? D latch is also known as a transparent latch. Also, D latch is also known as a transparent latch. So D latch is also known as transparent latch and implemented used to input. So D data and the clock signal. Okay. The output of the latch followed the input at the D terminal long and as long as the clock signal is high. When a clock signal goes low, the output of the latch is stored and held until the next rising edge of the clock. Okay. Truth table of the D latch in the below representation of the truth table of the latch. Okay. In which enable things is given, the data is given 0010 So in this case these are giving not input, but in 10 it gives 01 and in 11 it gives 10. Okay. Okay. So logic diagram for the D latch and logic diagram for the D latch is look like this and look like this. Simply not get okay, and two input, one is this one is not get, and before this we have put AND gate of connected by the one enable signal and not get from the one. So one data is provided to this one and second one not at the signal. Okay, pass it to this AND gate, one signal to the NOT gate. Now another is said to be enable state. Okay, this one this and this to this. Okay, Q and Q dash. This is a logic diagram for the D latch. Okay, a logic diagram for the D latch. So D latch is known as the transparent latch, and in which two input given, one is data and one signal. Okay, and when a signal is 1 and data is 0, then output return at the Q and Q dash is 0 and 1, whereas when we provide 1 1 on both sides, the output return 1 0. Okay, D latch. JK latch has a two input J and K. The output get toggle when J and K input are output get toggle when J and K are high. Okay, so latches are just like a SR latch, but it eliminates the undefined state of the SR latch. So as we see in this previous section, SR latch, set and reset latch, implement event set and reset. When input S set output and R is reset, then the both SR latch output to be 1. Okay, so 0 is undefined state. When 00 is given, it is undefined state. Okay, undefined state. when s is set to low and r is set to the 1, and the output will be q is equal to low and q dash is equal to high. So to remove the undefined state, we use jk, 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 jk latch, and it will element the undefined state of the jk latch. Okay. So in this three things are j, k, and one next step of the output. Okay, in this state. Okay. So let's see. Uh, when we have to make a truth table for the jk level, so j is given 0, 0, 0, 0, 0, 1, 1, 0, 1, 1. So after that, in which q plus 1 is equal to q. Okay, 0, 1, 0, 1, this is 1, and 1 is equal to q dash. So first of all, no changes. Reset everything. Set and toggle. Okay. So whenever we have to make the logic diagram for the JK flip flop, we simply use NOT gate. Okay, then NOT gate. One input is coming from the AND gate. This is output to this one. Another is coming from the this one, but different, and K not K not R N S Q and Q dash. Okay, this is a logical diagram for the JK flip flop. Okay. After that, T latch. So when JK input of JK latch are sorted, we get a T latch. So T latch, the output get toggle when the input are high. Output get toggle when input are high. Input are high. Everything is similar to like our JK, but this time we have to provide a clock. Right now, simply one input is not, and another input is given to this one. This one input given to this one. This one is JK, but wherein in this case, one input is given to this one input is given to this one. Okay, both are connected. Okay, by J, and another T portion is given to this one. Okay, which clock is given. The advantage of latches. Some of the advantages of the latches are listed below. So easy to implement, low power consumption, high speed, low cost. Okay. Disadvantage is no clock, unstable state, and the complex timing. Okay. So we cover the all the information about the latches. Okay. Mm, cover the all the information about latches. So let's move forward for the all the flip flops. So okay, let's discuss our flip flops. So let's discuss about flip flops. Okay. So in previous discussion we discussed about the latches. So latches is a digital electronics device. Latches is a let's see. So latches is a digital electronic device in which one bit of information is provided until it get stored when the new updated value is not fed. Okay. So what is definition? It is a data circuit that stores one bit of info until the new stored, and it is for the temporary storage, and we can implement using and not and NAND gate. Okay, and in which there's two stable state. Okay, and clock that do not use clock is known as latches. Okay, if you put on when we have to move from the NAND gate, you simply S dash to Q, R dash to something, and for the NOR gate using RQ, S and Q dash. Okay, whereas in flip flop, so flip flop is a circuit. Flip flop is a circuit that maintain a state until is directed by the input to change the state. Okay, digital circuit. So flip flop is a digital circuit maintain a state until directed by the input to change the state. Okay, the basic flip flop can be constructed using 4 NAND gate or 4 NOR gate. A flip flop is popularly known as a basic digital circuit, basic digital memory circuit. Okay, there's two types: two state logic one and logic zero state. A flip flop is a sequential circuit. A flip flop is a sequential circuit which consists of a single binary state of information or data. A digital circuit is a flip flop which has two output and are of opposite state, and it is known as bistable multivibrator. Okay, so flip flop is a basic. Actually, flip flop is a digital memory unit circuit. So it has two state, either one high, either low. So digital circuit of the flip flop has two input, and both are in opposite state, and it is also known as bistable state. So it is a sequential circuit which consists of the single in a binary state of the information. Okay, so simply types of flip flops. So simply just like same as the latches. So SR preset reset, JK, D, and T. Okay, so SR flip flop would help to present and clear when input is switched on. Okay, one is set and another one is reset. It is designed initial to set a reset the flip flop that is initially state. Okay, uh, flip flops in which we provide the block diagram for this one is S and R preset, and this one. So in the flip flop with the help of preset and the clear option. So preset and clear option. When a power is switched on, the state of circuit keep on changing. That is uncertain. Okay, it was come Q is equal to 1 and reset is equal to 0. Okay, in many application it is desired that initially state of reset flip flop that is initially state of the flip flop. These things are accomplished by PR and clear. So for the SR50 and set and reset things are given, a clock signal is provided, and preset and declare thing will be out will be there. Okay, so latches in which we see the clock uh, clock one. So logic diagram is we have to use the 4 NAND gate. Okay, mm, okay, NAND gate. Mm. In JK flip flop, okay, JK flip, the basic structure of the JK, the basic structure of the flip flop which consists of the clock, clear, and preset. So JK, preset, clear, everything. Okay, so similarity. So if we see so if we see mm, create a two NAND gate connected, given S and given R, both are connected by the clock, and the this input goes to this output and this input to this one. Okay, but for the JK, another one provide this one. So for JK have to provide this one, simply one extra state. JK and D flip flop consist of the datas and the clock for the two input Q and Q dash. So there is no D flip flop. So D flip flop is D and clock, preset and clear, everything is given. So this one simply we provide Mm, one is connected, another is knotted by this one. Okay. The flip-flop, T flip-flop simply this one. This one is very complex. Okay. The click on the data input T and the clock is equal to this one. Okay. So we see the difference between we see the difference between latches and flip-flop. So the question, what is latch? Okay, so latch is a data electronic circuit. It provide a single unit, single bit of information. So single bit of information until when the new data, a new updated input is not fed. So actually it is a memory unit, and it is actually a memory unit. Okay, memory unit, and it has a two stable state, and the latch is simply a flip flop without any clock pulse. Okay, so widely it is used for the storing, the temporary storing. Okay, and it is sensitive to the low voltage. Okay, the types of flip flops are SR, D, JK, and T. SR latch, D latch, JK latch, and T latches. So in SR latch, set resisting, in JK, um, JK flip flops, SR latch, and the D latch, in which it is also known as transparent latch, in which only data and the clock signal is provided. Okay, clock or enable thing is given. Okay, whereas flip-flop is a digital circuit, and flip-flop is a digital circuit that maintain the state directed by the input to change the state. Okay, flip-flop is a sequential circuit which consists of single binary, and flip-flop has a two output but are in the opposite. It is also known as a multi-vibrator state. So it is a basic digital memory circuit. Okay, SR flip-flop and JK. So in which new thing is that a preset and the clear things is given. Okay, so we cover this one, difference between latches and flip-flops. Okay, transparent latch is known as D latch. Okay, when we have to explain what is race condition in electronic condition in digital electronics. um, Electronics. So the race condition. So um, so whenever we ask to explain what is race condition, so race condition occur in a digital circuit when two or more signals change the same time at the same time. So actually, when two or more signals change at same time, and the final output depend on which signal which arrive first. Okay, this happened due to the propagation delay in a logic circuit. This happened due to propagation delay in the circuit because all the gate have different propagation delay. So when two signal race to change the output, the faster one will be win. So what is master slave configuration? Okay, okay, till now we cover everything. So that's all for the today's session, in which we discuss all